Okay, I'm about to go up on the roof. We need to talk about angles of depression and angles of elevation today. So take a trip with me up to the roof. I've got my trusty beanie here, making sure we're always safe when we're going up in high places. So here we go. Come on with me. All right, let's open the hatch. Beautiful day. Let's see what we got. All right. Whew. Wow. Looking out over the fields. Gorgeous. Okay, so what we're going to talk about today is angles of elevation and depression. The general rule of thumb we're dealing with here is that an angle of elevation or depression is determined by me looking out and drawing a line to the horizon of my eye level. So if we look out, you in general can see I'm going to consider my eye level the horizon at this point. And so what we're going to do is, you can kind of see that water tower out there. We're going to use that horizon line as a frame of reference. And so an angle of elevation and depression is determined by that eyesight level when you look out. So as I look out over the baseball field here, I'm holding the camera at eye level. If I am measuring what it would take to look down at something, like the electrical box, or the barrels, or if I'm looking down at the concession stand over there, that is an angle of depression. If I'm looking below the horizon line. So anytime you have to look down, that would be an angle of depression. An angle of elevation, however, would be anytime I would consider the horizon line and then look up. So for example, I'm walking to the corner of the roof here so that we have a better view of the cell tower over here. And if we look out to the horizon line, I have to look up to look at the top of the cell tower. And so that is an angle of elevation because I'm looking up. So if I had to look up at a bird, if I had to look up at an airplane, anytime I'm looking above the horizon line, that's an angle of elevation. All right, so let's work on this today in our lesson. And remember, so depression is below, elevation is above. All right, let's look at what we got. Welcome back. This is 8.4 angles of depression and elevation. You saw the basic explanation of this in the introduction. And so an angle of elevation is generally looking up from level with the horizon. And an angle of depression is generally looking down from level with the horizon. And so part of the deal with this is classifying things as they are. And so in example one, we're going to look at that. Up here you see a bird, and here's a guy on a cliff. So he's on a cliff. This is a tree, and so the guy is looking down off the cliff at the tree, and he can look up at the bird. And so when we classify angle 3, we are talking about angle 3 from the bird's perspective. Well, if we see this red line, this is the horizon line for a bird. And so angle 3 would be an angle of depression because the bird would be looking down. The bird is looking down, so it's an angle of depression. Angle 4, however, is up from the horizon for the man. So this is going to be an angle of elevation, because the man would have to look up at the bird. So it's the angle formed between the horizon and the line of sight to the bird. See if you can figure out 5 and 6. In 5, he's looking at the tree. In 6, the tree is looking up at the man, so to speak. Let's use trig ratios to actually solve a problem using this. An air traffic controller at an airport sights a plane at an elevation of 41 degrees. So here's the air traffic controller, and here's the plane. They look up at a 41 degree angle. They notice that it's the 4,000 foot mark for the plane. So the plane is 4,000 feet. We can figure out the horizontal distance between the plane and the airport using trig ratios. Let's notice we have 41 degrees and we have the opposite. Whoops, accidentally opened that up. We have the opposite of 41 and we have the adjacent, and that tells us tangent. So the tangent of 41 equals 4,000 over x, and we'll multiply by x on both sides, and then divide by tangent of 41, divide by tangent of 41. So x is equal to 4,000 divided by tangent of 41, and that gives us 4,601 feet. That's trig ratios. This is just a word problem that has to do with trig ratios, and it helps us understand angle of depression and elevation. See if you can solve this next one. Instead of 4,000, we have 3,500, and the plane is at a 29 degree angle. See how far from the airport that plane is. You might want to draw a picture. So round to the nearest foot, try to draw a picture. We'll talk about it in class. Last example. We're going to use an angle of depression this time. There's a ranger standing on top of a tower that's 90 feet tall. He's looking down at a forest fire at a 7 degree angle. So his line of sight is here, and it's a 7 degree angle, and he's 90 feet off the ground. Well, if I notice, I've got two parallel lines. The bottom of this triangle and his line of sight are parallel lines. And so alternate interior angles tell us that this must be 7 degrees also. When I see that, that makes it a lot simpler to figure out what we're talking about. Because now, if I want to find the length from the tower to the fire, I have opposite and adjacent. So the tangent of 7 equals 90 over x multiplied by x, divide by tangent 7, divide by tangent 7, and I end up with x equals 90 divided by tangent 7, which gives me 733 feet. So not that far away, but that's what it gives me. Alright, you can try the next one. Notice the angle is 3 degrees. See how that affects the horizontal distance, and solve it in the same way? Might want to draw a picture. Alright guys, so that's angles of elevation and depression. Not too complicated, but make sure you're taking notes and trying those examples. We'll see you next time.